Welcome back to another AP Computer Science multiple choice practice video. In this video, we're going to be going over some multiple choice practice problems. So let's go ahead and jump into this one. This first one says, a certain social media website allows users to post messages and to comment on other messages that have been posted. When a user posts a message, the message itself is considered data. In addition to the data, the site stores the following metadata: the time the message was posted, the name of the user who posted the message, the names of any users who comment on the message, and the times the comments were made. For which of the following goals would be more useful to analyze the data instead of the metadata? Another way that you could phrase this question is 3 of these can be answered with just the metadata, and one of them it would be more useful to analyze the data. So we're kind of trying to find which of these 4 goals would we need just the message itself or the data to figure this out. So let's go ahead and go through them line by line. So the first one says to determine the users who post messages most frequently. So take a second. Do you think that's metadata or data? So I would say that this one uses our metadata. Okay, so most frequently, this implies that we need to be looking at the time. So the time that the message was posted is the metadata. And then we also need to figure out the user that does that. So the name of the user who posted the message is also metadata. So we're not actually using what the user posted in their message at all to figure this out. So I would say A is not the right answer. For B, to determine the time of day that the site is most active. So once again, you can see the time of day. So what we would be using there is the time the message was posted metadata. We don't need to know what users are posting about at all to figure out when it's most active. We can just look at the metadata. So B is also not the right answer. With C, to determine the topics that many users are posting about, I would actually say that this does use data. Okay, so remember that the data is the message. To figure out the topic of a message, you have to actually look at the content of that message. You can't figure that out using the time it was posted, the name of the person who posted it, or the names and the times that the comments were made, right? You need to actually look at the substance of the message to figure out the topic, to then figure out which are maybe the trending topics, if you wanted to compare this to Twitter, for example. So I would say C is the right answer for this problem. Let's go ahead and see why D is not the right answer. So with D, to determine which posts from a particular user have received the greatest number of comments, also not the right answer. So here we would need to use the name of the person who posted the message and then also the names of anyone who commented on them and the time that they were made. So we only need metadata to figure out which posts have received the greatest number of comments. We don't need to care about the content of the actual post, only the metadata. So the correct answer for this problem is C. Moving on to the next problem, this one says the figure below shows a robot in a grid of squares. The robot is represented as a triangle, which is initially facing upward. The robot can move into a white or gray square, but cannot move into a black region. Okay, so we have our robot down here, and it's facing up. And the robot can't move into these black squares, or black regions, I guess we're calling them. So then it says, consider the procedure move and turn below. So we have this code here, move and turn. It accepts 2 parameters, number of moves and number of turns. And as you might imagine, number of move controls how many times we move forward, and number of turns controls how many times we rotate or return. Okay. So then the problem says, which of the following code segments will move the robot to the gray square? So let's sort of look at our diagram again and let's see where we're trying to make it to. It looks like the end goal is this here. So I think with this problem, I think it kind of helps if we try to figure out how we want the robot to move instead of looking at the answers and quickly deciding on one of them. Okay, so we can kind of break this up into 3 steps. As you can see in the solutions here, there's we're gonna move and turn, move and turn, and move and turn again. So you can kind of think of it as here's that first segment that we want to go through. Here's this next segment that we want to move. And then here's this last segment that we want to move. So we can kind of say step 1, step 2, and step 3. Okay. Each of one of those is going to be a move and turn call. So this first move and turn call, what do we want to do? So we want to move forward twice. And then what do we want to do? Then we actually want to turn. We want to turn such that we're facing this direction. because we're going to be rotating to the right, it looks like we're just going to need to rotate once. So I would say that this first call that we need to move and turn, we need to move twice forward and we need to rotate once. Okay, so why do we need to rotate once? We're initially facing up, and then we need to rotate to the right so that we're facing to the right. Okay, so let's go ahead and see if any of the answers have move and turn 2, 1 as the first step. Okay, so it looks like A does not have that and actually has it swapped. So I'd make sure that you're noticing that the first one is for moves and the second one is for turns. Okay, so this one has it swapped around a little bit. So A does not work. B does seem to have 2 forward moves and then a turn, so that one still seems promising. Same with C, and it looks like D, we're going to end up moving 3 times forward, which is not correct. We want this to be 2. All right, so that kind of helps narrow things down a little bit. Let's go ahead and move to the second step of this movement. Okay, so now we can say that we are facing this direction, facing to the right. Now, how many moves forward do we want? We want 1, 2, 3, 4, and then we want to be facing upward so that we can continue with the third step. So if we're moving from facing that direction and we want to now be moving this direction, we're going to need to rotate 3 times. Okay, so here's what our rotation is going to look like. We're going to rotate right once, we're going to rotate right again, and then we're going to rotate right again. So we're going to be having 4 forward movements and we're going to be having 3 turns, such that we end up in the final position facing upward again in that box. So let's go through the rest of our answers and let's see if we can eliminate any of them. So it looks like with B, we have 1 as the number of turns instead of 3. So this should be 3. You might have selected this answer if you didn't notice that we're rotating right instead of rotating left. So say, for example, you thought that we were rotating to the left, then, we wouldn't need these intermediate steps. We could just rotate once to the left. But since we are rotating right, we need those intermediate steps. We need to be having 3 turns. So I would say the correct answer here is C, but let's go ahead and do the third step of this procedure just to make sure that we have the right answer. So with the third step, we're going to want to move forward once, twice. And we don't actually need to turn at all, right? We've made it to the gray square, so we have accomplished what we were setting out to do. So I would say here we need 2 moves forward and 0 turns. So that does match up with this final step for C. So yeah, the correct answer here is C. I would say with this problem, make sure to not do it too quickly. Make sure you know which parameter is which so you don't mix them up. And yeah, just make sure you're doing it slowly. Moving on to the next problem. This one says an office building has 2 floors. A computer program is used to control an elevator that travels between the 2 floors. Physical sensors are used to set the following Boolean variables. So we have on the floor 1, which is true if the elevator stopped on floor 1, otherwise false. On floor 2, set to true if the elevator stopped on floor 2, otherwise set to false. Call to 1, set to true if the elevator is called to 1, otherwise false. Call to 2, set to true if the elevator is called to floor 2, otherwise set to false. So the elevator moves when the door is closed and the elevator is called to the floor that is not currently on. Which of the following Boolean expression can be used in the selection statement to cause the elevator to move? Okay, so the first time I read this, I was actually kind of a little bit like, what is this even asking us? So let's go ahead and break it down a little bit. So let's say we have these 2 floors, 1 and 2, and we have some elevator, and it's either on floor 1 or it's on floor 2. So if it's on a floor, it's going to be either on floor 1 or it's going to be on floor 2. So here it is on floor 1, here it is on floor 2. And then we also have these other 2 Boolean variables, that is call to 1 and call to 2. So if, for example, there's someone waiting on floor 2 and someone calls the elevator to floor 2 and the elevator is called up, then we would say that call to 2 is true. If, say, for example, the person is down on floor 1 and they call it there and the elevator moves down to floor 1, then we would say that call to 1 is set to true. We need to find the Boolean expression for when the door is closed and the elevator is called to the floor it's not currently on. So those are the 2 sort of situations in which the elevator is currently moving. So let's look at this first situation where the elevator is on floor 1 and someone calls it up to floor 2. We would say that this is a situation in which the elevator is moving. So what needs to be true? Well, what needs to be true is that the elevator needs to be on floor 1. So on floor 1, that needs to be true. What else needs to be true? It needs to be true that someone actually called the elevator to a floor that is not currently on. So we also need and call to 2 to be true as well. Those two things need to be true. If, for example, we said on floor 1 or call to 2, then what would happen is if the elevator is just on the first floor and no one has called it to the second floor, this would evaluate to true. So true or false equals true. But that is not an elevator that is in motion. That's an elevator that's stuck on the first floor. Okay, so it's very important that we have an and here so that if our elevator is not currently being called up to the second floor, then this would evaluate to be false instead of true. Okay, so we need to use that and. So we can go ahead and eliminate answer C and D because they use that or for that first situation. We need an and. We need an and such that if it's on floor 1 and this person called it up to floor 2, this would be the elevator is in motion. Okay, so now let's look at the opposite situation. So this is the other way around. So it's on floor 2 now, and someone calls it down to the first floor. I would say we need on floor 2 to be true. So we need it to be on the second floor. And we need for someone to have called it down to floor 1 and call to 1. Once again, we need those two things to be true. If we had an or here, what could be true? So if we had it's on the second floor, yep. Or let's say, for example, no one has called it to the first floor, so it's just staying there on the second floor. This would evaluate to true, but the elevator is not actually moving. So we don't want to be using an or here. We want to be using an and. So what happens if we convert this into an and? So true and false is going to end up evaluating to false, and that would be true for the situation where the elevator is not in motion, it's on the second floor, it's just standing there. If we change this to a true, and now someone is calling that elevator down, we would say that true and true is equal to true. So the elevator is in motion here. So you'll notice that both of our answers have the and there. I just wanted to eliminate any possibilities that this was an or. The only difference between A and B are this or this and here. Okay, so let's kind of think about it a little bit. Is it true for all 4 of these variables to be true? Why or why not? If we want one of these to eventually evaluate to true, such that the elevator is moving. If you said that A cannot be true, you would be correct, okay? It's not possible for the elevator to both be on floor 1 and on floor 2. And this statement needs all 4 of those booleans to be true at the same time. At the same time, it's not possible for call to 1 and call to 2 to both be true as well, because it's already going to be on some floor. You can't call the elevator to the second floor if it's already on the second floor. Same with if it's on the first floor, you can't call it to the first floor again. Okay, so I would say A is the incorrect answer here. And so why is B the correct answer? Well, we have our 2 different situations where the elevator is either on the first floor and someone calls it to the second floor, or it's on the second floor and it's being called to the first floor. So this or, so let me put a little, this cannot be true. So this or helps us combine these 2 situations such that if everything here is true, or the other situation, everything here is true, then the elevator is moving. The correct answer here is B. I hope this helps you out with these AP Computer Science Principles multiple choice problems. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.